Good day, everyone. All right, so today we're going to be recapping solving parallel and transversals that have three variables, such as x, y, and z. We're also going to be learning new information, such as induction and counterexamples. All right, let's get going. All right, so right here, we need to solve for either x, y, or z first. In this case, we're going to solve for x first because there's two of them. So we can find that really quick. All right, so in order to find that, we are going to look at just these where those angles are. So we have this angle with an x is located here, and this angle with an x is located right here. So we're looking at these two angles right here, just specifically. Now, in order to help me out, I should have a piece of paper, and we're going to look at this, and what we're looking at is it acute or obtuse, those angles? So we know that if they're the same, such as they're both obtuse or they're both acute, so if they're the same, then they're equal to each other. If they're different, they're going to add up to 180 degrees. That's everything in a nutshell. All right, so this angle at the top here, so this angle is greater than the chord for my paper, which is 90 degrees. It is bigger than 90 degrees, so that's obtuse. And then this other angle is less than the chord of my paper. See how it cuts into it? So this is big, this is small, those are different. So that means that they're going to add up to 180 degrees. So a plus b equals 180. Now you just need to actually do it. So we have 18x minus 44, that's the first one, plus the 8x minus 10, which is the second one, or vice versa, doesn't matter, equals 180 degrees. So now we're just going to solve. So when you solve that, and you know how to solve it from this point on, but I'll just go a little speed racer. 18 and 8 make 26. Negative 44 and a negative 10 make negative 54 equals 180. We're going to add 54 to both sides. So just in case you need my calculator, need to know what's going on in my head. All right, so what did we do? We had 18 and 8. That got us at 26. Then we had that negative 44 and that plus that negative 10, or negative 44 minus 10, whichever. That's negative 54. Okay, so now we're going to take the 180. We're going to add 54 to both sides. We get 26x is equal to 234. And then we're going to divide by 26. And that gives x equals 9. So that's what's going on in my head. So all that right there, we found x. What are you supposed to do as soon as you find x? We're supposed to plug it back in. So let's go ahead and do that. So we're going to plug this back into the calculator and solve for each of those angles. So I'll zoom out a little bit. All right, so right here. So we have 18, and we're going to multiply by 9 minus 44. And that is 118. So this angle right here turns into 118. And then this angle right here, 8 times 9 minus that 10, and we pop out with 62. So this disappears to make 62. So now all of the big obtuse angles are 118. So, and all the small angles, which are the acute, are 62. So let's see. This one's acute, so that's 62. This is obtuse, so that's 118. This is acute, so that's 62. And then rinse and repeat. This is obtuse, that's 118. This is acute, so that's 62. And this is obtuse, meaning big, and that is 118. So we found all of the corners. This one simple action of finding x and plugging it back in helped us find all these angles. And then from this point, everything gets wicked simple. So what we're going to do is we're going to find y now. This angle has a y in it, and we also have the number. This angle is 13y minus 38. It is also 118. They are the same angle, so they are equal. And now all we have to do is solve. So in my calculator, I'm going to solve for this. So all we did was set these two things equal to each other. That's it. So we set them equal, and now we're going to solve. So 118. I'm going to add 38 to both sides. I get 156. And now I'm going to divide by 13. I get y equals 12. And I'm going to plug it back into the picture to make sure it makes sense. So plug it back into the picture to make sure it makes sense. So here we go. So 13 times that 12 minus 38. I should have popped out with 118, and I do. So that's telling me I'm doing this right. Awesome. One less thing, right? Okay, and then let's find z. Hey, look. This has a z in it, 10z minus 2, and this is 118. So they are the same angle. So once again, if they're the same angle, they are equal. So 10z minus 2 is equal to 118, and all we have to do now is solve. So I'll use my calculator so you can see what I'm looking at. So 118, I'm going to add that 2. So I get 10z is equal to 120, and now I'm going to divide by 10. And I get z equals 12. Now, a lot of people accidentally put the answer as 10, but you'll catch your mistake if you plug it back into the picture. So we have 10 times 12 minus 2. It popped out 118, and that's what it was supposed to be. So that's telling me once again that I'm correct. So those are the three answers. So we found x. We plugged it back in. Now that we have these angles, we can find all of the other angles. We solve for both the y and the z. So if they are the same angle, they are equal to each other. And always plug it back in to double check that it made sense. All right, so that was number 11. Okay, let's do one more. Let's get a little more difficult. Let's actually go down to number 16. So we're going to go down to number 16. All right, let's zoom in a little bit. All right, so this one gets a little tougher, right? All right, first of all, we should definitely highlight the parallel lines. So this simple action is going to save a lot of time here. So this and this are parallel to each other, and that will help us focus. All right, so let's see. I want the x's. What train took you from one x to the other? Now, this does not make sense to most of us in this class because the parallel lines, we always want them to be horizontal. So we're going to turn this paper. This makes sense to us. So this right here, we're focused just on this. So I'm going to zoom out a little bit. Focus just on this where we have this parallel line, boop, boop, and this red. That's all we care about. That's the train that took us from this x to this x. So this is a train. So this right here, from this blue to this red, is located, just focus right here, is located right here. So I'm going to put a dot right there. Now this x, so I jump from here to here. This x is located at the top left corner. So we're going to put that here. That is all we're focused on. So let's zoom in a little more. So if we focus on this, so we're only focused on this dot. Now, I cannot trust my picture because I'm the one who drew it, and everyone knows I can't draw. So what we're going to do is, that just helped us focus. We're going to use that picture to help us focus and jump back here. Now, is this acute or obtuse? Is that big or small? So is it acute, meaning small, or obtuse, meaning big? So this is big because it's bigger than the corner of my paper. So that's obtuse. And what about this bottom one? This bottom one, same thing. That is also obtuse. They're both big angles. If they're both big angles, do they equal or do they add up to 180? Are they equal to each other, or do they add up to, or are they different, meaning they add up to 180? So in this case, they're both the same. They're both big. They're both obtuse. So that means that they're equal. So we're saying, basically we're saying obtuse is equal to obtuse. That's basically what we're saying. So let's actually solve it. So 15x minus 26 is equal to 12x plus 1. All right, let's solve it. So I'll get out my calculator so you can see what's going on in my head. And I'll zoom out a little bit. Here we go. All right, so I'm going to do 15. I'm going to subtract that 12 from both sides. And I pop out with a 3x minus 26 equals 1. I'm going to take that 1. I'm going to add that 26 over here. I get 3x is equal to 27. And now I'm going to divide by 3. I got x equals 9. Huh. I just happened to get x is 9 again. Awesome. And what are you supposed to do as soon as you find x? You always plug it back into the picture. All right, so we're going to take this. We're going to plug it back into this picture over here. Zoom out just a little bit. All right, so wherever we saw an x, we're going to plug that back in. So that is 15 times 9 minus 26. We pop out with 109. So this right here is really 109. And over here, 12 times 9 plus 1, we got 109. And they were supposed to be equal, so I feel really good about that. So that's perfect. Okay, so now that we have that, let's zoom in a little bit. Now we have that, let's find the next angle. All right, let's see. Okay, if this is 109, now if I go back to this picture, remember how we said this, so this picture right here, this is 109? Well, we can actually find a bunch of other angles. That's 109. This right here would be 109. And then what would be left over? So 180, subtract 109. From blue to red would be 71. This is 71. And copy paste. All the obtuse angles are 109. All the acute angles are 71. So we can apply that to here. This is 109. From blue to red, the acute is 71. This angle right here, blue to red, that's 109 because it's obtuse, and this is 71. Hey, looky here. Now we can actually find this this angle right here, this y, which is not out here, it's in here. That's where the arrow goes. And you guys see this triangle right there? What do the angles of a triangle add up to? They add up to 180 degrees. Okay, there are 3 angles of a triangle. So 28 in this case, 109, and the third one is at 4y minus 9 equals 180. All right, so basically we have that 180. If we took out that 28 and that 109, then 4y minus 9 would be 43. Okay, sweet. So let's actually solve. So we're going to add 9 to both sides. We get 52. Divide by 4, and y is equal to 13. So let's plug that back into the picture to see if that worked out. Let's see. 4 times 13 minus 9, that is 43. So this angle right here is 43. And all 3 of these angles are supposed to add up to 180 degrees. 28, 43, and 109 add up to 180. Everything's checking out. This is awesome. Okay. And finally, this angle right here. This is a Z. And we actually know from blue to red, all this blue to red right here, and it's obtuse, that is 109. So this angle right here is actually 109. So this angle is 20Z plus 11. It is also 109. They are the same angle, so they are equal to each other. So let's solve. I'll zoom in. All right. So we have 109. We're going to subtract that 11 from both sides. We get 98. We're going to divide by 20, and Z equals 4.9. And that is the final answer. Yes, you are able to get a decimal. All right, sweet. All right, so if you need to take a picture of that, copy that down later, rewatch this video, any of that, please do so. All right, so that's awesome. So that was just a nice review of those. Okay, now let's go ahead and go to page 9. So we're going to flip to page 9 now. So we're flipping to page 9. And let's actually get into our notes for today. All right, so our notes. Here we go. Inductive. So inductive reasoning, that is making a conclusion based on observations and patterns. So you just follow a pattern. That's it. You just follow a pattern. There you go. So a conjecture is a concluding statement reached using inductive reasoning. All right, so all that happy jazz. Okay, so we saw a pattern, and now we are going to make a sentence about that pattern. Okay, here we go. So on this one, we're going to do number 1 and 2. Okay, how do we get from 38 to 31 and then to 24 to 17? What do you think that pattern is? What do you think that pattern is? All right, so I think the easy thing is adding and subtracting. Let's see if that works. So I use my calculator, 38. To get from 38 to 31, I subtract 7. And if I do it again, subtract 7 again, would I get, yeah, I would get 24. And if I subtract 7 again, would I get 17? Yes, that's the pattern. I kept subtracting 7. All right, so what would be the next numbers? So if I continue that pattern, subtract 7, I get 10, 3, negative 4, negative 11, and negative 18. So I just kept up that pattern. All right, so what was our, what did we do? So to generate this, to generate the next term, subtract 7 from previous term. That's it. Okay, now if you didn't want to write all of that in one big thing, your key thing that you said was just subtract 7. So if you just kept subtracting 7, I can roll with that. So if you just wrote minus 7, you got the right idea. Okay, now let's look at this next one. How did we get from 2 to 5? Okay, I added 3. Okay, so if I add 3, let's see. So 2 plus 3. Okay, if I add 3 again, that's not 11, is it? So that doesn't work. You're not always going to get it right the first time. So let me zoom in a little more. All right, so you're not always going to get it right the first time. So let's try something else. Well, let's see. How do we get from 5 to 11? Okay, now if I look at that, I doubled it and added 1 to it. So if I take the number 2, if I double it, then I add 1, I get 5. Okay, awesome. Now take that 5. So if I double that and then add 1, do I keep up the pattern? Yeah, that works. Okay, what about the next one? 2 times 11 plus that 1. Ooh, I think we got it. So what we kept doing was we doubled it and then added 1. So we just had to find a pattern that works. So if we keep up that pattern, so 2 times what? It would be 23 plus that 1, we would get 47. If we put in 47, we get 95. If we put in 95, we get 191. So I'm continuing this pattern, right? So we got 23, we got 47, 95, 191. All right, let's keep going. Oops. All right, so if I put 191 and add 1, I would get 383. And let's do it again. 383. We pop out with 767. All right. So now what was our conjecture? So what was the pattern that we found? So basically we just double the previous term and add 1. But if you just say, if you said times 2 plus 1, I can roll with that. So as long as you have the right idea, I'm down. All right, sweet. And that's it. So just anything basically about that idea, I'm happy. All right. So, and we're going to be doing the next problems, at least one each day to keep up this pattern. All right. So that right there, that's inductive reasoning. All right. Flip the page. Number 10, counterexamples. Super simple. Counterexamples. So for counterexample, that is an example that shows the conjecture is false. An example that shows the conjecture is false. So basically, like if I say like every student in the classroom is wearing red, all I have to do is find one kid who's not wearing red, or George is wearing green. Boom, George is my counterexample. That's it. It doesn't matter that there's a ton of kids who are wearing a different color. All I need is one person, one object that is disproving this. All right, so the sum of any two consecutive integers always add up to odd. Let's see. I'm just going to do some examples real quick. So 1 and 2, well, that makes 3. All right, as long as they're the next numbers, consecutive numbers. Okay, how about, I don't know, 5 and 6. So 5 and then 6 is right after that, and that pops out as 11. I would keep going, and I can't think of any example. So everything checks out. I would keep going, but I cannot think of a single example where this is false. So this is true. All right, let's go and move on to the next one. The product of two integers is always larger than either number. All right, product. That means times or multiplication. Two numbers, so is always larger than either number. So the product is always larger than either number. Well, let's see. So product, that means times. So if I do 2 times 5, that equals 10, right? But can I think of any numbers where if I multiply them, it's actually smaller? Well, a good guess to that is anything that is a fraction. So if I say, I don't know, like 1/2 times 6, that would equal 3, right? And that is smaller than those numbers. Okay, so it said the product of two numbers is always larger than either number. And this right here is that's smaller than this, but it's and it's so this one checks out because it's larger, but this one does not. So another example would be if I did yeah, that's about it. Yeah, that's pretty awesome right there. Another good example would be 0 times 5, and that would be 0. So once again, that is smaller. So so times, boom. So I've actually found 2 examples. So this right here is false, and my counterexample this would be a good counterexample, and that's it. That's everything that we need to learn for today, and I hope you have a great and awesome day.